Okay, thank you very much, Ken, and thank you very much to Alan and the team from CITA for hosting me here and the rest of the speakers. It's really a privilege to be here and see the presentations of the competition. I know that there was an expectation perhaps to have a larger number of teams, but wow, the 5 have presented amazing work that has been accomplished in just a week, and I'm certainly impressed. I'm not an architect, but a civil engineer, structural engineer by training and construction management by research and practice for years. So I'm going to talk about a lot more practical issues of building modeling, and in particular about the flow of information and how much the flow of information affects the way that people work on site and in contracting in general. Perhaps just by way of quick introduction, we have a virtual construction lab where, of course, we do a certain amount of virtual reality work, but really when I say virtual construction in terms of research, it's that we're trying to research phenomena that happen in construction in the lab, not necessarily with virtual reality. And so our 2 foci are lean construction and building modeling, and then, of course, the synergies between those. So we have work, quite a wide range of work and techniques in the lean construction world, and the same in the building information modeling, and a lot of technology too. But really, we've been putting a lot of effort in the last number of years to building prototypes for systems and then running field experiments and virtual experiments to try to sense what the impacts of information flows on the construction sites will be. So I'd like to address it in these 3 aspects: the product information, the information about the building; the process information, the information about what's happening, who is there, who is not there, where materials are, what's happening in the supply chains; and then to talk about how we can improve the flow of both of those on site to make things better. And the real question we want to ask is, will this distance the client from the builder or bring them closer together? And when I say client here, even the clients, of course, are a number of levels deep. And so if we think about this simple situation where John Smith goes to build his house, and it's a simple job, and he has a builder, and the 2 communicate very directly. Where do you want the light switch? Oh, I'd like it here, and the builder or the electrician puts it there. The communication is direct, immediate, short-term, and presumably has fewer errors. But of course, in all the organizations that we're involved in, life is not like that. It's more like this, where the organizations are far more complex. And there are different commercial relationships, there are business relationships, there are engineering relationships, design, constraints, and so on, that mean that kind of information, where the same John Smith has bought an apartment in a big apartment development in a neighborhood, needs to go through a number of, we have this on automatic, a number of different people in order to get that information to the builder. And oftentimes, the walls that we've built between those are such that the information gets through erroneously, of course. And so that's really what we're going to ask. The basic framework, the theoretical framework we're working from, how do I get this to stop? The basic theoretical framework we're working from is this lean BIM interaction matrix, which we put together a number of years ago with my colleagues, Laurie Koskela and others at the time who were at Salford, where the column headings are lean principles, the rows are BIM functionalities, and we try to identify in the different cells, which are green, the different ways that these 2 ideas, or technology and principles, could interact positively. So when you use BIM, does it make your construction leaner? When you're doing something, and then you have the red cells, there are very few, which represent the opposite. You're doing something with BIM, like, for example, automatically producing drawings, and that tends to increase your tendency to make all the drawings at the end in a big batch, which is actually working against the flow of information through the life of a project. So there are also negative interactions. So on the basis of this, we've continued and developed different prototypes, tools, worked with companies, And we want to explore and investigate how many of these actually happen in practice. So having set that background, let's talk about controlling the quality of product information. And of course, I can't cover the whole range of how we do this, but I'll just pick up simple examples to show you what I mean. So we're talking here about clash checking, construction detailing, virtual design and construction to avoid rework. And then we're talking about pool detailing, prefabrication, and so on. And then I'm going to give you a quick example about this product information and talk about interoperability. So let's head into this. Well, of course, the clash detection part of it, everybody's familiar with. It's clear from the teams and from the audience that this is a no-brainer. It's what Chuck likes to call, or Paul Teichholz likes to call the low-hanging fruit. It's the first benefits we get. But then we can talk about from the coordination going on to 2D, from 2D to BIM, from BIM to virtual design and construction, and then from VDC to pool flow, to lean flow. So what do we mean by these? Well, if you think about a traditional 20 years ago, the world of CAD or of drawings, really what we did was we had some design, and then we produced some drawings. They went through to the contractor perhaps, or to somebody else to do detailing. They would produce some more drawings, would do some 2D coordination on Chuck's light table, and then to construction. And of course, the construction had all of the problems that we're aware of. Now we come along and we say, well, we can do building modeling, and we can do some 3D coordination. And so we have here now a slightly different workflow where we're going to take the initial drawings, model them, create the models, improve them, and then produce drawings and do the construction. Well, that's okay. That's still clash detection and so on. But we can go a bit further than that. And we can do what is generally called virtual design and construction, where when we do the modeling, we're not doing the modeling just to do the design. We're doing it to test how we're actually going to build the building. So in this case, really, we want the models to be built by the contractors. It's an exercise in prototyping. It's not only an exercise in design. And the most important thing that we're doing here is we need to cut the flow of information from the drawings to the site and replace that, entirely rerouted through the model, so that we can get control of what happens on site from the model. And here's a quick example of how this happens. Here is a very unsophisticated site, although it's a 60-story office building in Tel Aviv. But on the right-hand side, what you see is not a drawing. It's a sheet of views of the model produced by the modeler from which the people are working. So they're working directly from the model, rather than from any pre-prepared drawings. But of course, we'd like to take that yet another step, and this is something that I've not seen done yet in real ways. In the lean paradigm, we don't want to do any work until it's both mature and required. So we really want to have the construction on site pulling the detailing. So we're not going to detail any zones in the building, floors, areas, rooms, whatever, until we're ready to actually fabricate them and build them. Because if we do it ahead of time, we're building up inventory, we're building up batches, and we're setting ourselves up for rework. So these kind of pull signals coming back from the site through the chain, back to the modeler, back to the detailers, is where we want to go, so we can reduce cycle times as far as possible. And then talking more about the product information, I'm going to move us to an area that we've all, I think, in the research areas have been involved in for many, many years, at least 20 years, since IFC began and so on. And that is this challenge of interoperability. How do I take models from tool A into tool B? And so we have, through the benefits of building smart, we have the IFC, which is excellent in as far as it goes. But still, as you see on the red arrow here, there are still problems. And I think any of you who've worked with IFC and with Exchange are aware of the kind of issues that we have. So one thing that is improved is that we have now model view definitions. So we have model view definitions that tailor the IFC export for particular needs, like in this case, the CV is the coordination view, and then we can import it into some other tool using that model view definition. And we can do that over and over again, and the United States National BIM Standard defines a process by which we define model view definitions, but we define them for different domains. So in fact, it's a pleasure having Manu Venugopal here from Autodesk, because Manu previously was a PhD student at Georgia Tech, and Chuck and I had a joint project where we developed one of these MVDs for the area of precast concrete construction, and Manu took part in that. A lot of work, very intensive, very highly detailed, and the problem is that in the end, if we need to have model view definitions for every domain, we get back to the original problem where we have a lot of different n times n minus 1 over 2, in fact, exchanges to prepare if we're actually to make this happen. Now, the problem is a little bit ameliorated because we can encapsulate them and have what we call semantic exchange concepts. And true, but nevertheless, we're still doing a lot more work. So one of the ideas that we've come along and said is we need to change that product information in the following way. We need to put the onus for the semantic content on the importer rather than on the exporter, because the importer knows exactly what they need. Now, I'm personifying a software, but the importing software, the writer or the author of the importing software knows what the internal data structure is. They know what they want to get in terms of concepts. And if I show you this model, what do you see? It's a Tekla model. What is it? Volunteer? It's a car park built from? Precast. And these things on the top, the slab elements, they're precast double T's with an in-situ topping. So you can immediately see, I didn't tell you that that's an IFC object that has the material precast and so on. We're all trained as professionals to see what we see. And so the question becomes this: whatever is in that IFC or Tekla model, it's being modeled by someone in some particular way for their own needs, in their own tool. But when they export it, there is much more implicit information there than it is explicit. Of course, there's a great deal of explicit information, but it's not complete. If I wanted to do energy analysis or cost analysis of this, it would require a lot of work for me to filter that. In fact, Living FM spent a whole week trying to figure out how to do this for FM. You need to take those models and add to them a great deal of semantic meaning before you can use it for facilities. So the idea says this: let's take these models, let's try to create an engine that can capture the knowledge of experts and then interpret what we're seeing and add it to the model for whatever purpose we want to add it for. And we rely on the fact that these models they express the form and the function and behavior of the objects that they show, with various relationships between objects. So we say this: can we build a tool that we call CBIM? CBIM stands for Semantic Enrichment Engine for BIM. And the idea, I will show you briefly, is that we create a set of inference rules that you see here. I have a pointer. A set of inference rules, and they get processed by the runtime rule processing engine and try to enrich the model. So if I look at this, for example, a set of hollow cores, anyone can tell that in model 1 we have a slab, in model 2 as well. You can tell in model 4 that the 3 on the left work together, but the 1 on the right should not be aggregated with them, at least not for structural analysis. So you can then say, okay, the receiving software that knows about precast needs to have this IFC structure. Those beams need to be aggregated as a slab. And so we put together a prototype software, we call it CBIM, and within the interface, you can create rules like if the object is a beam element and it's made of concrete and it conforms to some size constraints and so on, and then perhaps if some object is adjacent to some other object along their long face, and whatever rules I could glean from an engineer, we can implement, and then we can run it through, and what we get is the same IFC model, but this time it's been enriched with all the aggregations, all the connections, all the joints, all the different things that a precast engineer would like to have in that model. We've tested this for a number of different domains, and one interesting one is exactly this issue of cost estimation. So you take a model like this, and the question that was raised, this was done by a PhD student of mine and a PhD student at Georgia Tech, named Shiva Aram. So you look at these columns, and the precast engineer would say, well, I can't fabricate or manufacture a column of 6 stories. I can make one of 3 stories. Where should I make the break? Well, I should make the break behind the spandrel that's closest to the center of the column in its height. So you write the appropriate rules, and you can do it. So you say the right spandrel is the one that's half height of the building, and etc. A series of rules, and the spandrel is the closest to the center. And there you can now break the column for casting. Another thing that we're trying to do now, and this is a proposal we have before the European Union, is to do the same thing for bridges. So we can do laser scanning. We've heard a great deal about laser scanning. What we want to do is to be able to take the laser scan, get the 3D objects, but then even after we have the 3D objects, we'd like to not just classify that as a beam, but we'd like to also be able to say that there are connections, that there is some, what material it's made of, how it was made, and so on for that bridge. And so there can be a very wide range of applications. So we're beginning to see that we will be able to enrich models in such ways that we can have a wide variety of uses for them, and that we can perhaps begin to overcome the interoperability problem also in this way. Well, let's talk for a moment about the process information. So in the process information, especially in the lean construction world, we're very much concerned with production planning, with workflow, with waste along the workflow. And so let's look at these. Again, simple examples. There's the notion of the 4D CAD. Well, 4D CAD can become much more powerful when we apply it to standardizing production. So here we have a building where we can model out all of the formwork for concrete pours. And in a building like this, it's built, this is a typical project that we've worked with. The formwork for the walls, for the exterior walls, is the stonework is prepared on the ground, the stone cladding on the form, tied to the form and so on, and the forms are lifted up and cast and then brought back down. So the sequence in which you use the forms and rotate them through the floor is critical to getting a good workflow. So the company we've been working with have been doing this, and then they've brought this down to a fine art of being able to get the precise sequence, particularly here, where there are mirror-imaged buildings, and the formwork has to serve both buildings so that they're not purchasing or fabricating too much formwork. And they've been able to do that very effectively. Another thing they've been able to do, once the structure of a building is complete, it's very difficult to use the tower crane to bring finishing materials into the floors. So they have advised the idea of bringing the materials into the floor before the floors are cast. So they'll use the cranes at night to bring in all these pallets, as you see here. So again, BIM has allowed them not only to detail out all the masonry work to figure out how much they need, but also to place them correctly so it's not going to interfere with the shoring. And the result is an enormous saving in terms of maneuvering or delivery of materials into the project afterwards. And then in the production planning, we tend to work very much with VICO software, mostly because of the location-based planning that allows us, opposite the BIM model. This is a project where there are 20 buildings. We're seeing 5 of them here, 3 of 9 stories, 2 of 22 stories, and then they repeat 4 times. And the line of balance chart has been worked out very, very carefully to make sure that the flow of work is minimal. The inventory of apartments in progress, the work in progress, is minimized. And so that also allows them to have teams flowing from one building to the next, and also formwork and other equipment. But then we get this question, which is a very challenging one in lean construction. Well, we know that we want to have good workflow. Good workflow is less waste, but how do you know? You have a project running, and you get a line of balance chart, and as made, like that. Well, which of these have the best workflow? I'll show you again. The lines represent the work of a crew on a particular floor that's listed here on the left. For those who are less familiar perhaps, a continuous line is a good line. Breaks in the lines, like here, represent places where crews are waiting. If they're working here parallel, it means they're working in more than one place at a time, also not good. There are a number of features of these things that we can immediately identify as good or bad. But we would like to be able to measure that. We'd like to be able to measure the performance of construction managers on site, Are they achieving good workflow, or are they not achieving good workflow? It immediately impacts their budget and time. So in the lean community, how many are involved in the lean community of practice or have some background in lean? Okay, so you've all heard of the percent plan complete. And that's the major index used in the framework of the last planner system, but the truth is, it does not measure workflow at all. So we have, in different research, developed this lean workflow index, which depends on these different parameters: the standard deviation, the production rate, breaks between activities, the times the crews are working, the amount of work in progress, work out of sequence, space out of sequence, and so on. And when you compile all those and consult a forum of experts about the weights to be applied to each of them, we're then able to provide a lean workflow index. And as you can see, if you compare the red to the red or the blue to the blue, the lines at the top are PPC measures from projects. The other lines are lean workflow index. They actually don't correlate. So PPC is not a very good measure of the workflow that you're achieving. And we can do this now in a 2-week cycle so that it's a real-time measure. And management can say to project managers here, we demand that you achieve at least 5. If you're not achieving 5, check what you're doing in a production system because it's not working well enough. Okay, and finally I'll talk about how we bring these perhaps together a little bit. Well, this is a very typical Vsm value stream map, in this case of rebar procurement done by a construction company. And the part I want to emphasize here is this. It's about rebar, how you do the detailing, send it to the fabricators, get it back, tie it in place in the port. Net working time is 8 days, but the gross time that it passed is 30 days. So it means that their cycle time for ordering rebar and getting it into the site is 30 days, when actually that could be done in 8 days. And there are areas in construction, many of these areas, where the amount of savings are much bigger than we tend to think of. If we ask those rebar tires to work a little bit quicker, or give them overtime or something, maybe they could work 5% faster for a few days. But these potentials are much, much higher. So when we think of a lean or a traditional construction, oftentimes we have this make-ready process, but it's very short, not done very well. And then we do a lot of make-and-do, because we get to the site and we're trying to do some work, and the material hasn't arrived, and we've got the wrong materials, or the drawing's not up to date, and so forth, so we improvise. The ideal in lean is the opposite. It's to say invest a lot of time in the making ready, in the preparation, so that you can then work first time correctly, as we heard from Mercury and DIT is the goal, the nirvana. But in an ideal world, even if we understand lean and we try, we can't really achieve that. We remain in the construction world with a degree of uncertainty. And it's here that we can begin making a difference with information. Because the more we can reduce that uncertainty about the process, the better our production systems will be with less waste. And so we can map out the decision making. All I wanted to show here is that whether we like it or not, construction crews, when they're on site, they reach these, what we call them go, no-go decisions, where they reach a point and something doesn't fit. Do they abandon that work? Do they go somewhere else? Do they improvise? Do they do something else? So to try to address this, the first prototype we built something like 6 years ago, we called CAN-BIM, which is Kanban and lean pool production, and BIM. And what that tried to do was to visualize the process, the product, reduce WIP, filter constraints, in other words, the make-ready process, to report process status and implement this language action sense of making commitments. Part of the idea of using BIM and a platform for this was to say, if you want to teach people a new way of thinking, give them a tool which will allow them to work in a way which will then reveal to them a different way of thinking. So the last planner system, which is one of the main tools that is used in lean construction, has this cascading planning paradigm. And what we're doing here is we're adding a daily, an hourly, if you like, information system that updates on status and allows people to make commitments. What this looks like is this. I'm going to just skip for a moment. We have the master planning, the phase planning, the weekly work planning, and the workflow control. And if I just focus for a moment only on the weekly, on the production control, then what we're doing is in these prototypes, you might do planning in this way. You have the model, you create the activities and map them. And then you would have these weekly work planning meetings where the different trades are sitting around the same table with the planner, and they're looking at the model. And what they're seeing on the model is a series of labels, and each label represents a task, an activity. And as you can see, some of the tasks have these green triangles, and some have red, and so on. What those represent, I'll just get back, what they represent is this idea of maturity, that a task to be done has to have materials, information, space, preceding work, safety, and so on. But all of those things might not be 100% ready, and if they're not, we run into problems. So if we were able to track through ERP systems, through supply chains, and so on, the status of all of those make-ready issues, constraints, we could inform people about what the status of activities are, so that they don't begin activities which are not mature. And the second index we can show them is a thing we call the pull flow index. What we mean here is, as I said, we want to keep work in progress as small as possible. That means if I have 3 or 4 activities I can go and do in a week, different spaces in the building I might be able to work in, what I really want to do is to choose the ones which allow follow-on work and follow-on and follow-on and allow that space to be completed. If I go and work in a space that's ready for me but not ready for the next activities because it's subject to design changes or some other hold, then I haven't added value. I haven't reduced the amount of work in the system, and that's a pity. My work has I have progressed, but I can't progress the project. So that's the second symbol that's showing up here in the star symbols. And the way it works in the planning is that each subcontractor makes their own plan for the coming week, perhaps in different areas of the building. You can see here, for example, in the main lobby, the gypsum team have decided to work there, and so has the electrician. And so this is now put up straight up on the weekly work plan. The team together can then say, show me what that looks like. Well, it's going to look like this. And now we can have a consultation, a very quick, fast consultation. Is that practical? Will the electrician be able to put in that electric board while the scaffolding is there for the gypsum work? Perhaps not. If not, we need to reschedule. And that can be done in the weekly work planning. So we had a prototype of this and tested it. Worked out the workflows. The way it works is that people on the site can then report what their status is. They can say, I can start work, I report that I've started using my iPad or my smartphone or whatever, and then work in progress, and then it's stopped. If it's stopped, they'll call in help, and so forth. The benefit of doing that is that we get the information back into the system, which then becomes visible for everyone else. So in terms of the original last planner, we're adding maturity assessment, we're adding pull flow task assignment, and we're adding constraint monitoring and updating all the time. And we don't have time now, but there are in YouTube, if you look for the CanBIM keyword, you'll find a number of movies that show this in different experimental situations, on site and in our virtual construction site. And then, as the years have progressed, 2011, 12, and so on, we've started to see quite a proliferation of startup companies who are offering software that begin to do this. Our plan, recently purchased by Autodesk. BIM 360 and various applications, Smart Use, Advanced. Soblono is a German startup. Procore, there's another one now called Stant, which is a Brazilian startup. And all of these try to provide spraying of information. They sit in the cloud, they use building modeling, they give process information and sorting and so on. But there are a number of features that, at least in our view, following this through in the research, are missing. And the missing features, I hope you're making notes. The missing features are some of these. In the experimental work, we found that the more that subcontractors, trade crews, use systems like that, the more familiar they become with the work in progress of others, and they begin to do social networking amongst themselves, which provides in itself coordination that improves production. So many of them have asked us, can we use this at home? Can we have this sort of, so we thought of creating a thing called Sitebook instead of Facebook, where they could communicate among themselves and coordinate the project. very willing to collaborate, surprisingly willing to collaborate because it improves their productivity. Team development and collaboration, which I mentioned. Work planning. From a subcontractor's point of view, it's not enough to plan this project. They're working at the same time on multiple projects. They would like to be able to plan their resources across projects. In fact, projects are competing for resources all the time. If a subcontractor were able in a system like this to see multiple projects and plan their following week with the clear knowledge of the maturity of the work at each site, without having to go and visit, or without having to believe the, I don't want to say lies, but the requests of the project managers for 10 laborers when they actually know there's only work for 5 or 6, then they could do that. Task maturity assessment is another thing that's missing, and of course the pool flow assignment. So we've just begun putting together another research prototype that will try to add those in, and it has interfaces of this kind. We call it ICANN. Really what we're trying to do here is create online feedback of constraints, ubiquitous reporting of process status, and agile negotiation among subcontractors about the work to be done through the network. But we have a lot of questions here, like how do we evaluate the effective information flow? Can we measure the change in the impact it has? How can we evaluate the effect of the social networks that are generated? Do the social networks have more power than the technology, perhaps? And if so, can we engender social networks in other ways? I have another student who has been trying for a few years something we call the social subcontract, which takes its idea from Jean-Jacques Rousseau's social contract, where individuals give up some of their own personal freedoms and rights for the sake of belonging to a state or an organization or society, and then enjoy the win-win of stability that society provides them. By the same token, subcontractors in certain situations can give up on their own freedoms and work in order to collaborate with others to create a win-win. So then, I guess I'll wrap up and say that the question we began with was, will this distance the client from the builder, or will it bring them closer together? And so we observe, and we've done a lot of work on this issue of client changes. And in this case, it's not just the principal client, but the apartment owners who have purchased apartments from the real estate developer who actually are working opposite the contractor. And this kind of statement is very common. And so we began with this idea where I'm the apartment client and I have my own builder and there's no problem with the flow of information from me to the builder. And the situation that we've created over time, that society has created, the construction industry, because of its fragmentation and all the other problems that we're aware of. One of the companies we're working with has begun modeling thoroughly all of the individual apartments. These were done in a project that has 1,036 apartments. Every single one, I mean, there are typical apartments, but every one is modeled. And the clients are brought to sit opposite the model, and all the changes are recorded directly in the model. The result of that is that because that model is communicated directly to the workers on site, the electrician who needs to put in that outlet is looking at the same model that might have been updated yesterday by the client and is able to put it in place. Now, I'm not saying that that's as good as the client being there and pointing and saying, but it's becoming a lot closer. And so perhaps that flow of information can be far more direct and far more apparent and transparent, perhaps, than our very complex systems have made it up to now. So I'll conclude and ask perhaps, where do we stand in terms of that theoretical framework, the matrix I showed in the beginning? Well, in this particular construction company that we've had a very close research practice relationship with over 4 years now, they're already doing most of these things, and each one of them is one of those cells on the matrix. They're doing a number of others. So we are making progress, not just in the adoption of BIM, but in the synergistic adoption of BIM in terms of their lean goals. If I go back to the matrix itself, and again repeat, there are 56 green cells. Of them, we've identified so far that about 25 are working. They've been implemented now. The matrix has helped them guide what they're doing to fulfill them. But as you can see, there's still a lot of green potential. There's still a lot of green field for us to exploit. But interestingly, there are also these 2 red cells up at the top. Those are things simply that we did not predict, but that have turned out to be very synergistic. And perhaps there will be more as we go along. And what's next? Alan, in his email a week or 2 ago, said, can you please address the future and what it means for the Irish construction industry and how government should be involved and so on. Well, I think we are heading towards much more ubiquitous access to product and process information, including on the site. And we've seen all these startups. We know now that Autodesk has gotten deeply involved in this. A discussion earlier with the people at A-Site make it clear that perhaps some of this can be implemented using A-Site in terms of workflows and monitoring. I think we're going to see much deeper integration of ERP systems and supply chains, information systems with company-wide information. And by that I mean process control information, project management information. And then hopefully we'll also begin to see the detailing and the supply of information, of product information being pulled rather than pushed. We will presumably see a lot more social networking among subcontractors. I don't know if any of you have seen this, but amongst subcontractors on unsophisticated construction sites, what's the most popular collaboration tool? WhatsApp. Because you can create a group, you can share photos, you can share texting, and it's very quick, very open, no overhead for setting up. In many cases, the GC won't even know that it's happening on their site. Planning and control across project boundaries and across company boundaries. It's essential for subcontractors who are spread in a different way, in a sort of a horizontal way across projects, rather than GCs focus on vertical projects. If they're to get the benefits of the win-win, this becomes a key feature. And so perhaps we could summarize all of those points by calling it much deeper collaboration through shared information and reduced risk. And here I might conclude by, there was a question asked earlier about how do you encourage collaboration? How do you get contractors to collaborate? What's the incentive? Well, part of it is to look at why they don't collaborate. And that has to do a great deal with risk and their sense of risk and protecting themselves. There is a lot of game theory work, we discussed a little before, where you can use economic game theory to show prisoner's dilemma and then development from there, that when people lack information, their risk rises. When your risk rises, you behave more defensively. When you behave more defensively in our context, it means you're risk averse, and so you act in a way that reduces your risk but doesn't necessarily increase the benefit for the others. When you have better information, what they're calling in game theory the information gap is reduced, you can then begin to behave less risk averse, more collaboratively, and we get what in game theory is called the win-win situations. So perhaps more pervasive information, more transparency about what's going on a construction site, or for that matter in a construction project beyond the site. What is the status of information, of drawings? What is the status of material deliveries? Will general contractors make all that more transparent to their teams of subcontractors? If that happens, I think we will see much more willingness to collaborate on site. So thank you very much.
Thank you, Rafael. Thank you very much. We have some time for 2 or 3 questions. If anybody has questions at this stage for Rafael. I think Alan might have the microphone.
I'll come over to Paul.
The lean community are closer to the front here, Rafael,
yeah,
so they'll be asking you.
Go ahead, Paul.
Just could you elaborate maybe to the audience on some of the methods you use to teach lean construction in your university?
The methods used to teach lean construction?
Yeah.
Yeah. Well, our approach is such, it says that what lean construction is offering us is not new tools and techniques per se, but it's offering us a new way of thinking about construction, about how construction production is done. And that has to do with adding, our typical understanding of how construction works is that raw materials are converted into finished products. We take bricks, we put them one on the other, we get a wall. And that we call the transformation view of production. The problem with that view it works, it's fine, and it's at the root of critical path method and a lot of other methods of construction management. It's at the heart of bills of quantities and costing, because each line item is a product. But the problem with it is that it hides a lot of activity that goes on beyond just putting block on block. And those can be activities like delivering materials, creating the drawings, rework, a builder, a bricklayer waiting because the bricks didn't arrive, or the information was wrong, or something else, or the supply chain is not right, or the weather wasn't good, or the scaffold, whatever. So it turns out, as I showed in the one example there, that most of the waste that goes on is hidden in the unit prices. And when we focus only on those transformations, we don't see what goes on between them, the delivery, the waiting, and so on. So we have in Lean, Cascading did a very wonderful work where he explained that we can think of construction in a different way, which is called the flow view, and a third way called the value view. And in the flow view, we think of construction as things flowing. Materials flow, labor crews flow, they move from place to place, and if we follow them, we can see that there are times when they're working and there are times when they're not working. And we can have much bigger benefits in terms of increased productivity by reducing the non-working time than actually by focusing on how better we can lay the brick on the wall. So we try to teach our students right from the get-go, second, third year introductory courses to construction management, that there are 3 different ways of conceiving or thinking of construction production. And then we use different games. There are a range of different games that we can use to show that waste, to show the impact of variability and instability. In graduate studies, we have courses that focus on lean construction, and then it's a lot more about how you use the tools, how you realign production systems and so on, leading on to IPD and other more sophisticated topics. But I think I would just emphasize that what we're trying to do is not to tell them that this is some other way of doing things, that this is a good way of doing things, and that's how they should be practitioners.
Anybody else? Perhaps I could just ask a quick question. You referred to working with one particular contracting group, I think, as part of your research.
Mm-hmm.
Have they calculated the amount of money they've saved through all of the work with yourselves?
Well, no, but I think that we will undertake that exercise. They're a company that build in the region of 3,000 homes a year. It's fairly standard, and we have a situation where there is a great lack of housing, and so the demand is very constant. The government released land for construction at a fairly steady rate, which is a good thing. We agreed to work with them fairly exclusively because they provide us absolute free entry to all their sites and collaboration and so on. So we have this living laboratory for our PhD and master students. But I can give you one example that relates to building modeling. Recently they began this project of, as I said, 1,000 and something apartments. They, for the first time, set up a big room. They demanded that the engineers, architects, all the designers send their representative to work in this big room setup. They went from, in a typical project of this kind, from 0 to getting permits for building is usually about a 14 to 16 month process. They did it in 6 months. Now they're both developers and contractors. For them, that 8 or 9 months of reduction in development time is, well, I don't know how to compute it, but I'm sure it's a great deal of money.
Yeah,
and that's just one example.
I think it's an issue that I think the community generally, they actually like to see real hard evidence. So the more we can produce evidence to convince people who are not totally convinced, and they're the sort of numbers I think will be useful to us in our country anyway, and indeed around the world. Have we one more question? John has one question here. Microphone, thanks, Al.
Rafael, I was interested in how much of a culture shift was it to begin working productively in lean construction for the companies that have done it, and how quickly do you think they have seen a value from it? And I'm talking really a monetary value,
right?
Another productivity or whatever way you want to put it.
Yes, of course there is a cultural shift here, a big cultural shift in the way that people think about what they do. In the standard practice of a general contracting firm of this kind, And perhaps many of you will understand this is familiar. The way that the industry has developed is that the way we run projects is that we run them through contracts. So as a GC, I would write contracts for each subcontractor, and I would try to make that contract as risk-free for me as I could, and shift all the responsibility to the sub, and the sub to their subs, and so forth. And then what I'm doing, in fact, is the project manager is not doing so much production management, they're doing contract administration. And I run it through fines or bonuses through the contract. And I don't actually know who the workers are. They're not of any concern to me. They're there and then they're not there, and whatever. To work in lean, we really need to take back production control. We need to be very concerned about how they're working. What are they doing day by day, hour by hour? And that's a big mind shift jump. But when it happens, then you see that the middle management in the construction company, the site supervisors, the site engineers, project managers even, are becoming a lot more concerned with the flow. We measure them, their lean workflow. That was never measured before. So they become much more concerned about making it possible for the subs to do their work right the first time with a good flow. And that is a shift. The subcontractors, we found, are much more open to the ideas because they see the benefit immediately. We have teams, for example, of ceramic floor tilers from China. They're there for 2-3 years to do work and go home, and they're interested simply in taking home at the end of the month as much money as they can in any given month. The company that we've been working with, and we're in research, but they're doing the lean, they tell us that over the past 2 years, the price that these teams quote them for flooring is about 12% lower than what they quote for other construction companies, and yet they still prefer to work for the company because the volume they can do in a month is bigger. So they're charging less and taking home more, which is, I think, a direct result of the production flow being more efficient. So it's a win-win for both. They're taking home more money and the company is doing the work for less.
And they're able to accomplish that almost as an island of lean.
Yeah. Perhaps up to this point in time, yes. And presumably competition will flow over and there'll be more uptake. No. Sure.
Okay, I think at this stage we will have some time for questions perhaps later on in the next session with Rafael, if you don't mind. But
sure.
At this stage, I'd like to thank you again.
My pleasure.